Good day. This lecture on demand is brought to you by the Philippine Academy of Family Physicians in partnership with New Market Link Pharmaceutical Corporation, a leading distributor of a diverse specialty line of global pharmaceutical products. I am Dr. Joan May M. Oliveros, and I am going to present a lecture on how to conduct systematic reviews and meta-analysis. In this lecture, we are going to learn what is a narrative review, systematic review, and meta-analysis. What are the preparations before conducting this type of research, the different steps in conducting meta-analysis, how to use the RevMan app, and how to write a meta-analysis paper. Meta-analysis refers to a process of integration of the results of many studies to arrive at evidence synthesis. It is essentially a systematic review. However, in addition to narrative summary that is conducted in a systematic review, in meta-analysis, the analysts also numerically pool the results of the studies and arrive at a summary estimate. It is a combination of results of several trials to produce a summary effect. This article is an example of a scoping review. Narrative reviews or scoping reviews are based on subjective selection of publications to support the objective of the study. The reviewer in a narrative review qualitatively addresses a clinical problem by summarizing the findings of other studies and drawing a conclusion from these findings. In a narrative review, there is no specific search strategy. The selected studies are not critically appraised, the strength of the evidence is not weighted, and no quantitative synthesis of the data. Therefore, narrative reviews are prone to biases and errors. A systematic review, on the other hand, is defined as a review using a systematic method to search and summarize evidence on a clinical problem with a detailed and comprehensive study protocol. Furthermore, despite the increasing guidelines for effectively conducting a systematic review, we found that basic steps often start from framing a question, then identifying relevant work which consists of criteria development and search for articles, appraise the quality of included studies, summarize the evidence, and finally interpret the results. Like for example, all study findings for a set of outcomes and interventions are identified, tabulated, and discussed in a narrative manner in a systematic review. Systematic review and meta-analysis follow the same study protocol steps. That is, frame a question, conduct a search, identify the right type of research, and then extract information from the articles. In meta-analysis, there is an implicit assumption that the studies have come from a population that is fairly uniform across the intervention and outcomes. The data can therefore be pooled to come up with a summary statistical estimate. In meta-analysis, the decisions are transparent, and the statistical analysis results in an objective measure of the integrated quantitative evidence, which can then be repeated and verified. Moreover, meta-analysis converts the results of primary studies into a common metric as the effect size. Thus, different measures from primary studies can be compared against each other and yield conclusions that are more significant. Some critics point out the mixing of apples and oranges in a meta-analysis study, where protocols, data collection methods, definition of disease, and exposures may vary from study to study. Another criticism is the issue of publication bias, where positive studies are more likely to be published, and hence there will be a bias towards finding a significant result. What are the decisions to consider prior to conducting a meta-analysis study? First, how many authors? The Cochrane guideline recommends 2 reviewers. The PFP recommends at least 3 reviewers. Also, protocol registration should be done for transparency. And let it be known that we have a PFP Research Committee registry, and the people behind it will provide technical support. What are the steps in conducting a meta-analysis study? First, frame a question based on a theory. Do the literature search. Select the studies for inclusion. assess the studies for bias, extract the data from the selected set of final articles, then analyze the data using the RevMan analysis, and finally write a report using the PRISMA guideline. The first step is framing a question. PICO is usually used for systematic review and meta-analysis of clinical trial study. For the observational study without intervention, in many tropical and epidemiological questions, it is usually enough to use the P and the O. In meta-analysis, we must indicate clearly the population, P, then intervention or exposure. It is also important to compare the indicated intervention with other interventions. Finally, we need to clarify which are our relevant outcomes. Intervention needs to be as broadly or as narrowly defined, keeping only the interventions of our interest. Usually, meta-analysis are done in assimilating studies that are RCTs, or quasi-experimental studies, where pairs of interventions are compared. Note that meta-analyses are not necessarily restricted only to RCTs. These are now increasingly applied to observational study designs as well. For example, cohort and case control studies. In these situations, we refer to the specific exposure variables of our interest. Meta-analyses are also conducted for diagnostic and screening studies. To validate the question, we can start by doing a simple search in PubMed or Google Scholar with search terms in PICO. This is a preliminary search to identify relevant articles, ensure the validity of the proposed idea, avoid duplication of previously addressed questions, and assure that we have enough articles for conducting its analysis. After the quick literature research to find major clinical trials dealing with this topic, we can then review the question to make sure it is correctly focused. Also, take this time to search for meta-analysis that may have already been conducted on the topic. Finding a recent meta-analysis on the topic does not automatically mean that you need to terminate yours. The existing meta-analysis might have a different focus, have used an inferior methodology, or is even outdated. For example, if I want to conduct a meta-analysis to determine if family-focused interventions are effective, my initial search terms will just be general, that is, diabetes mellitus and family. With this, the yield is 27,484 results. Then I can refine the terms to diabetes mellitus and family-focused or family-based, and the yield is now 337 results. This can now be reviewed. I can also limit the search to randomized controlled trials only, and this narrows the search to 38 articles. The foundation of a high-quality systematic review is the literature search. The search must be structured and logical, and each step must be recorded so that the process can be duplicated. The basic search strategy is built based on the research question formulation, that is the PICO or PICOS. Search strategies are constructed to include free text terms and any appropriate subject indexing, like your mesh. It may help to have an expert in the review topic or an information specialist. We advise first to use the terms P and I and S. In Boolean logic, you may use the connectors and, or, and not in various combinations to expand or narrow down search results and findings. When you search Medline or PubMed, you can use mesh terms to search for your studies. You can use mesh or combined mesh terms along with other terms to search more widely and more comprehensively. Besides this, you may use specific symbols such as the asterisk. For example, if you use something like diabet then asterisk to search for titles or abstracts, with that used terms, the term diabetes, diabetic, or diabetologist will come up. The improvement of the searched item or term is made while doing a trial search and looking for another relevant term within each concept from retrieved papers. In selecting studies for inclusion, The title and abstract must be screened by 2 or more investigators. Abstracts that do not address the research question are excluded. Also, duplications and irrelevant articles will be removed manually, but when in doubt, be inclusive rather than exclusive. The basis of decision to include or exclude studies are the following. If the study is irrelevant for the study question, not the relevant population, not the relevant intervention, nor the outcome of interest, it is in foreign language and cannot be translated, or if the study is a duplicate of another article. After deciding which articles to include based on the title and abstract review, the next step is to retrieve the full text of the articles. Some provide links for free to access full text articles, and in case not found, we can search in some websites which offer an option of direct full text request from the authors. In case the article is not found, then the reviewer has to purchase the article or subscribe. 3 more methods can be done to increase and refine the yield at this stage. First, search the reference list of all the included articles. Or the reviewer can do citation tracking or follow all related to or similar articles. After retrieving the full text, a second screening can be done. Papers are only excluded once both investigators agree that they are not eligible. At the end of this process, you should be left with all the available research pertinent to your research question. During this whole process, careful record must be kept of the number of excluded abstracts and trials as well as the reasons for their exclusion. Transparency and repeatability are key components of a well-performed meta-analysis. A flow diagram illustrating the study selection process must be included in the report. From these trials, pertinent data must now be extracted. The process of extraction should be executed by 2 to 3 independent reviewers. There are 3 parts to this process. The first is extracting demographic data. Also record the number of cases in each treatment arm. At the minimum, you must obtain the following information for each study included in your data collection form. When we extract the outcome data, if the outcome was measured on a continuous scale, determine the mean and standard deviation of the outcome both in the intervention and in the comparison arm. If the outcome is measured on a binary scale, then determine the number of people with the outcome and the number of people in the intervention arm, as well as the number of people with the outcome and the number of people in the comparison arm. This is a sample data extraction form in the PFP project. The second phase is to determine the quality of the trials. Each trial contributing data to your meta-analysis must be critically evaluated to determine how well the trial was conducted and what its risk of bias was. Was the trial randomized? Were the participants blinded? Were there excessive dropouts? And were the results reported consistently? The Cochrane database and the Review Manager, or RevMan, provide a risk of bias tool that allows these aspects to be recorded and visually presented. As described by the Cochrane collaboration, the emphasis should be on the assessment of the internal validity of the trial results. This should then be recorded as low, unclear, or high risk of bias for each trial. Finally, the outcome data you are interested in must be extracted for analysis purposes. This is the RevMan icon. You can download the RevMan for free from the Cochrane website. And let us try to analyze the following data using the RevMan app. When you open the RevMan icon, this will appear. You can just close this opening dialog. Then click Create New Review to open the review wizard. Afterwards, click Next. After clicking Next, you will be asked which type of review do you want to create. And for the specific study, we choose Intervention Review. So we click intervention review, and then press Next. Then type the title of the review. Afterwards, you click Full Review. Then press Finish. A window will show the title of your study that you will be reviewing. In adding a study, click the Studies and References icon and then press Add Study. At this point, the new study window will appear and you will have to decide how your study can be identified. For example, coffee and liver enzymes or Cochrane 2007. This time we will add the following studies for analysis in the RevMan app. In here, we can encode or insert the study ID, how your study should be identified. For example, we can enter the authors and the year of publication. So those two articles that you just added for review can now be viewed in this window, and you can do this step for all the articles you want to be added for review. In the assessment of bias, press the tables icon, and this will highlight the slide where you will see the characteristics of the included studies, including the methods used, participants, intervention, and the outcomes. In this slide, you will also see the risk of bias table. In the same icon tables, and when you scroll down the highlighted window, you will find the risk of bias table, which includes a list of bias items and the author's judgment for each risk of bias item, whether low risk, high risk, or unclear, and the author can also encode the supporting statements for such judgment. When entering data, we press the icon for data and analysis and then press Add Comparison. Once you press the Add Comparison icon, the new comparison wizard will appear and you can now decide what name should the comparison have. And then you press Next. From all the studies that are included or entered, it is now time to add the outcome. In our example, it will be about cure rate. When we press Next, this pop-up window will appear, which will ask what type of outcome do we want to create. Now, cure rate is a dichotomous data, that is cure or failure of treatment. So we press in dichotomous and then press Next. Another window will pop up upon pressing Next. Here we will be asked what name should the outcome have. So we will do cure rate and then we label the first group as inosine pranobex and the second group as control. Then we press Next. For the analysis method to use, we just use the default parameters. And we also use the same default parameters for our analysis details. For the new outcome wizard, we can actually revise the default graph details. The default outcome in RevMan is negative outcome like mortality, so lower than 1 relative risk. Left graph is better. Cure rate is a positive outcome, so higher than 1 RR. Right graph is better. Then we press Next. To edit other properties for the outcome, we can open the properties for that said outcome after clicking Finish. Before the wizard window is closed, we press Edit the new outcome. At this point, if you wanted to add further studies, when this comparative table pops up, we can click this icon to add another study. Then, choose the study you want to add. Afterwards, we can enter the data of all the included studies, both for the treatment group and the control group. This is how the table would look like once you enter the data for both the treatment and the control group. Once all the data are entered, now for both groups, we can now generate our forest plot. Press this forest plot icon, and then a window will pop up revealing the results. There you have it, a closer look of the forest plot generated from the studies included. And also it reveals the test of heterogeneity, including the chi-square test and the Ito test. If there is not much difference between studies, then that study is homogeneous. If there is much difference, then it reveals high heterogeneity and it is a cause for concern. It is important to determine the reasons for heterogeneity, like for example, the population, the intervention, and the outcomes may be different from each other. If the studies are homogeneous, we can say that the studies come from a population that is fairly uniform across the intervention and outcomes, and it will be okay to pull the results together. This may indicate that the studies you have identified are exhaustive, so you can use the fixed effects meta-analysis. In some cases, studies may be heterogeneous because they are not exhaustive and constitute only a sample of a larger population of studies. In this case, use random effects meta-analysis. Random effects analysis is only acceptable if the population, the intervention, and the outcomes are sufficiently uniform. Beside the forest plot icon is another icon that will generate the funnel plot for publication bias. A funnel plot is a scatter plot of the effect estimates from individual studies against some measure of each study's size or precision. The funnel plot is a method to assess the potential role of publication bias. If the studies plotted are evenly distributed in the inverted funnel, it means there is no publication bias. To assess the risk of bias, we click the icons, figures, and then we choose risk of bias graph. Then press next. Then it will reveal the risk of bias summary of the review author's judgment about each risk of bias item for each included study. It will also show the risk of bias graph, which is the review author's judgment about each risk of bias item presented as percentages across all included studies. This is a closer look of the risk of bias summary and the risk of bias graph. So are we now ready to write our meta-analysis research? Meta-analysis follows the PRISMA guideline, outline, or format. The title of the report must specify that it is a systematic review, meta-analysis, or both. The abstract shall contain the following information, and the introduction shall describe the condition, the intervention being evaluated, how the intervention might provide benefit, and why should the meta-analysis be conducted. Also, the objectives of the study are included. In the methods section, it is important to indicate if a review protocol was registered, and then provide registration information. Also, specify study characteristics and report these characteristics used as a criteria for eligibility. Also, describe all the information sources in the search and date last searched. Furthermore, it is imperative to present full electronic search strategy, even for at least one database, including any limits used such as that it could be repeated. Then state the process for selecting the studies, describe the method of data extraction from reports and any processes for obtaining and confirming data from investigators, and then finally list and define all variables for which data were sought. Also included in the methods section is the assessment of risk of bias of each individual studies, the summary measures, the synthesis of results, risk of bias across studies, and any additional analysis. The results section must include the flow diagram of numbers of studies screened, assessed for eligibility, and included, with reasons for exclusions at each stage. Then, the study characteristics, the results of individual studies including the Forrest plot, the risk of bias across studies, and any additional analysis must be included. This is the flow diagram using the PRISMA guideline. The risk of bias summary and risk of bias graph, the Forrest plot for the main results, and the funnel plot for publication bias. Finally, in the discussion section, we give the summary of the main findings, including the strength of evidence for each main outcome, the summary of evidence discussing the limitations at study and outcome level, including the risk of bias and at a review level, like incomplete retrieval of identified research or even reporting biases. Also, provide a general interpretation of the results in the context of other evidences and the implications for future research. Then we give our conclusions of the meta-analysis study and the references. This has been Dr. Joan May M. Oliveros. Thank you very much for your kind attention. Keep safe and God bless you always.